video, we're going to study chapter 6 of Aristotle's Categories as we continue working through this book as part of the Classical Liberal Arts Academy's Classical Reasoning 1 course. In our previous lesson, we went through chapter 5 and we studied the nature of essences or substances. And now we're going to move on to the second of the 10 categories and study quantity. So let's begin the reading of chapter 6. Quite a lengthy chapter here as well as we saw last chapter, but not nearly as long as chapter 5, but I'll try to keep comments limited to what's helpful and necessary as we read through chapter 6 together. So let's read of quantity, the second of the 10 categories. Of quantity, one kind is continuous, but another discrete. Let me just say, here, I didn't mention this in our reading of the first category of essence or substance, but what I should say is, once Aristotle establishes the 10 categories, what we see are all of the different branches of the philosophical sciences are established. Because once we, through philosophy, can identify the 10 true categories of things, we can then begin the philosophical investigation of each of those things, and that's where the different branches of philosophy comes from. This becomes very clear here in chapter 6, just because we're more familiar with the division of quantity. In the quadrivium, in the classical liberal arts curriculum, we already know that there are 4 classical mathematical arts: arithmetic, geometry, music, and astronomy. But if we were to ask, where do these arts come from? How do we pick these arts? How do we know that there are only 4? How do we know there's not more arts? Or how do we know that one of these arts actually isn't right and shouldn't be included in mathematics? The answer is in that very first sentence of chapter 6. Of quantity, one kind is continuous and the other is discrete. So if we take the second category of Aristotle's 10 categories, quantity, what Aristotle's telling us is that quantity as a most general genus divides into 2 species. And the 2 species of quantity are continuous quantity and discrete quantity. Now we're going to see that continuous quantity, we can call that magnitude, and discrete quantity we call multitude. And the continuous quantity is going to divide into the continuous quantity is going to divide into 2 subspecies. Continuous quantities which are at rest and continuous quantities which are in motion. The study of continuous quantities which are at rest is going to be the art of geometry. And the study of continuous quantities which are in motion is going to lead to the study of astronomy. Likewise, with discrete quantities, we're going to see that they divide into absolute and relative. The study of the absolute quantities is going to be arithmetic, and of the relative discrete quantities is going to be music. And so the division of this category, quantity, into its 2 species, and then of those 2 species into their species, is what leads us to the 4 arts of the quadrivium in mathematics, which is simply the philosophical investigation of quantity, the second of the 10 categories. Okay, so you should see that the true classical liberal arts curriculum comes from true philosophy. And that's why there's no alternative curriculum. because there's no alternative universe. There's no alternative rational philosophy, and consequently, there's no alternative philosophy, and consequently, there's no alternative curriculum. All right? So this is why the classical curriculum is so important to understand, because it proceeds from the existence of a system of knowledge, a true philosophy, and any other curriculum is an error or a moving away from true philosophy. So, as we study, understand that the education you're receiving is directly related to the content of the philosophy that we're studying. Okay, so let's get started with chapter 6. Of quantity, one kind is continuous, magnitudes, but another is discrete, multitudes. One consists from parts of a whole which have position with reference to each other, but the other, discrete quantity, from parts which are without position, that is, they're separate units. They're parts of a multitude, but the parts are separate. Discrete quantity indeed is such as number. Number is an example of a discrete quantity, and a sentence. But continued quantity or magnitude is such as a line, a superficies, a body, and besides these, place and time. For of the parts of number there is no common boundary of the parts of number. And realize when he says number, he's talking about discrete quantity. So don't get number and quantity mixed up. Number is a kind of quantity. Number refers to discrete quantity. All right? For of the parts of a number, if there are 7 things, and we look at the parts of that number 7 are 7 individual units. Okay? There is no common boundary through which the parts of that number are conjoined. Thus, if 5 is a part of 10, 5 and 5 are conjoined by no common boundary, but are separated. That's what the word discrete means. 3 and 7 also are parts of 10. They are conjoined by no common boundary, and in short, you cannot obtain a common boundary of the parts in number, but they are always separated or discrete, so that number belongs to things which are discrete. In a similar manner, also a sentence belongs to discrete quantity. For that a sentence is quantity is evident, since it is measured by short and long syllables. But I mean a sentence produced in conjunction with voice, a spoken sentence. For the parts of it are conjoined by no common boundary, because there is not a common boundary by which syllables are conjoined, but each of them is separated by itself. But a line is continuous. A line is a continuous quantity. That's why we study lines in geometry. For a common boundary may be assumed, namely a point through which the parts of the line are conjoined. The common boundary of a superficies is a line, for the parts of a superficies are conjoined through a certain common boundary. Now you see why boundary or endpoints are carefully defined in geometry. That's what makes a continuous quantity or a magnitude to be a continuous quantity. In a similar manner, also in a body, you may assume as a common boundary a line or a superficies through which the parts of the body are conjoined. Time also and place are things of this kind. For the present time is conjoined to the past and to the future like the parts of a line. Again, place is a number of things that are continuous. For the parts of a body possess a certain place, which are conjoined through a certain common boundary or endpoint. Hence also the parts of the place which each of the parts of the body possesses are conjoined through the same boundary as the parts of the body, so that place will also be continued, for the parts of it are conjoined through one common boundary. Farther still, some things consist from parts which have position with respect to each other, but others consist from parts which have no position. Thus, the parts of a line have position with reference to each other, for each of them is situated somewhere, and you can explain and show where each of them is situated in a superficies, and with which of the remaining parts it is conjoined. In a similar manner also the parts of a superficies have a certain position, for in like manner it may be explained where each of them is situated, and through what they are conjoined to each other. Thus also the parts of a solid and the parts of a place are conjoined. In number, however, getting back to discrete quantity, in number, however, no one can show that the parts of a number have a certain position with respect to each other, or that they are situated anywhere, or which of the parts are conjoined to each other. Nor can anyone show this in the parts of time. No one of the parts of time endures. And how can that have any position which does not endure? But you may rather say that the parts of time have a certain order, because one part of time is prior, but another is posterior. The like also takes place in number, because one is numerated prior to 2, and 2 prior to 3, and thus numbers may have a certain order, but you can by no means assume that they have any position. In a similar manner, likewise in speech, for no one of its parts endures, but it is spoken, and what is said can no longer be assumed. Hence, there will not be a position of its parts, since no one of them endures. Some things therefore consist from parts which have position, but others from parts which have no position. Those things, however, which have been mentioned are alone properly said to be quantities, but all the rest are so denominated from accident. For looking to these, we say that other things also are quantities. Thus, whiteness, we speak of it as a quantity when we say it to be much, because the superficies, the body which contains the whiteness, is great. And an action is said to be long, because the time in which it was performed is much. And for the same reason, motion is much. For each of these is not said to be a quantity by itself, Thus, if anyone should explain what the quantity of an action is, he will define it by time and say that it was accomplished in a year, or will explain its quantity in some such way. And explaining what the quantity is of whiteness, he will define it by superficies or by a body. For such as is the quantity of the superficies, such also he will say is the quantity of the whiteness. So that the particulars which we have mentioned are alone properly called quantities, essentially. But of other things no one is so called essentially, but from accident, or by a matter of attribute. Again, nothing is contrary to quantity. So just like essence, quantity does not admit contraries. For in definite quantities, it is evident that nothing is contrary, as for instance to 2 cubits or 3 cubits, or to superficies, or to anything of this kind. For nothing is contrary to them, unless perhaps someone should say that much is contrary to the few, or the great to the small. No one of these, however, is a quantity, but rather belongs to relatives, which is the third of the 10 which is the fourth of the 10 categories. For nothing itself, considered by itself, is said to be great or small, but in consequence of being referred to something else. In other words, great and small are not are not quantities, they're relations. We say that this is great, and when we say this is great, we assume the knowledge of the thing to which it's being compared. Greatness is a matter of relation, not of quantity. Thus a mountain is said to be small, but a grain of millet or a grain of wheat, we might say, is large, because the grain of wheat, may be greater in size than other grains of wheat or other grains and seeds. We speak relatively. We call the wheat grain large in relation to other grains or other wheat grains. The reference, therefore, is to something else, for if they were said to be small or great by themselves, the mountain could never be said to be small, but the grain of millet seed large. Again, we say that there are many men in a village, but few men in Athens, though there's a far greater multitude in Athens than in a village. We also say that there are many in the house, but few in the theater, though the multitude in the theater far exceeds that in the former. Farther still, 2 cubits, 3 cubits, and everything of this kind signify quantities. But great or small does not signify quantity, but relation. For the great and the small are surveyed with reference to something else, and hence it is evident that they are among the number of relatives. Again, whether anyone admits or does not admit that things of this kind are quantities, there is not anything contrary to them. For how will anything be contrary to that which cannot be assumed itself by itself, but is referred to another thing? Farther still, if the great and the small are contraries, it will happen that the same thing will at the same time receive contraries, and that the same things will be contrary to themselves. For it happens that the same thing is at the same time both great and small. Thus, something with reference to this is small, but the very same thing with reference to something else is great. Hence it happens that the same thing is at the same time both great and small, so that at one and the same time it receives contraries. Nothing, however, appears at once and the same time to receive contraries, as for instance in essence. For this indeed appears to be capable of receiving contraries. No one, however, is at the same time ill and well, nor is anything at the same time white and black, nor does anything else at one and the same time receive contraries. It will happen also that the same things will be contrary to themselves. For if the great is contrary to the small, but the same thing is at the same time great and small, the same thing also will be contrary to itself. It is, however, among the number of things impossible that the same thing should be contrary to itself. The great, therefore, is not contrary to the small, nor is much contrary to few. Hence, though someone should say that these do not belong to relatives, but to quantity, yet they will have nothing contrary. But the contrariety of quantity especially appears to subsist about place, for they admit that the upward is contrary to the downward, asserting that the place towards the middle is downward, because there is the greatest interval from the middle to the extremities of the world. They also appear to derive the definition of other contraries from these, for they define contraries to be those things which belong in the same genus most distant from each other. But quantity does not appear to receive the more and the less. As for instance, the quantity of 2 cubits. For one thing is not more 2 cubits than another, nor is there the more and less in number. Thus 3 or 5 of one thing is not said to be more than 3 or 5 of another thing, nor is 5 more 5 than 3 is 3, nor is one time said to be more time than another. And in short, in the above-mentioned species of quantity, no one of them is said to be more or less. It is, however, especially the peculiarity of quantity to be said to be equal and unequal. So here we have the peculiarity, the peculiar attribute of quantity. Quantities are said to be equal and unequal. That's the peculiarity of quantity. Thus, body is said to be equal and unequal. And also number and time are said to be equal and unequal. In a similar manner, too, in the rest of the above-mentioned particulars, each of them is said to be equal and unequal. Of the residue, however, such as are not quantities do not appear to be called equal and unequal. For instance, disposition is not entirely said to be equal and unequal, but rather similar and dissimilar. Whiteness is not entirely said to be equal and unequal, but rather similar or dissimilar. Hence it will be especially the peculiarity of quantity to be said to be equal and unequal. And this brings us to the end of chapter 6. So, most importantly, now, chapter 6, we may say, is a difficult chapter to comprehend. But one thing we always have to be careful of is that In these chapters, Aristotle often addresses objections or false opinions of other people, and then explains why their opinions are false. Whereas we're not starting with those false opinions. One of the things we have to always remember when we study Aristotle was that Aristotle was a historical genius in the sense that he was discovering truths and teaching truths for the first time in history. And he was teaching them in the context of other existing philosophies and teachings. And so when he taught things, he often had to give an account for his teaching. He had to prove his teaching. He had to disprove other teachings to establish his true teaching. And so in many of Aristotle's works, he spends lots of time dealing with false teachings and ideas that, frankly, we don't care about. We don't care about these things. We already know, living in 2021, 800 years after Thomas Aquinas already went through the works of Aristotle and proved them to be in agreement with Catholic faith. We already know that Aristotle is right and other philosophers were wrong. They've already been proven to be wrong over time. And so we're not coming to Aristotle with these objections that he's responding to and refuting. It's just like studying the Summa Theologica. When we study the Summa, St. Thomas Aquinas is often dealing with objections that we don't have. We already know, as Catholics, that St. Thomas Aquinas is the angelic doctor of the Church. He's answering objections of other teachers. But we don't have those objections. We're not making those objections. We're not coming into the study as believers in those other teachings. And so a lot of time studying all of the replies of St. Thomas to the objections and to the objections themselves is really unnecessary. And the same is true in reading Aristotle. I would say almost half or maybe even 2/3 of this chapter is responding to people who call relatives quantities, which we don't do. And so don't allow these digressions in Aristotle's writing to distract you from the real content, the positive content of his teaching. Hopefully, as your instructor, I can help you to avoid that problem and just focus on what I call the positive content of the teaching of Aristotle's writings. Now, as for chapter 6, the topic was quantity, which is the second of the 10 categories. He told us how quantity divides into species, into continuous quantity, which we call magnitude, and discrete quantity, which we call multitude. He talked about the characteristics of these two different species of quantities, and then he told us what the peculiarity of quantity is. What characteristic distinguishes quantity from all others, from all of the other categories? And it's that quantity is said to be equal and unequal. Okay? Quantity is said to be equal and unequal. That's the peculiar characteristic of quantity. All right, we said, just for the sake of review and comparison, in chapter 5, when we studied essences or substances, we said that the peculiarity of the substance, which is that the same thing being one and itself, through mutations that occur within itself, can at different times be contraries, or contraries can be predicated of the same thing at different times. That was the peculiarity of substance. Now in chapter 6 we've learned the peculiar characteristic of a quantity, namely that quantities can be said to be equal and unequal. Okay, so that brings us to the end of chapter 6. I hope that's a helpful introduction to lead you through your first reading. You've got to work now to master the content of this chapter for yourself, and I look forward to reviewing your work and your assessment, seeing you prove your knowledge of this chapter, and I'll be preparing the next video as we continue studying through Aristotle's categories. God bless your studies.